Right now, while you're reading these words, a machine the size of a small car is moving through a part of the universe where no human being has ever looked before. It was built before the internet existed, before home computers existed. It runs on roughly 4 watts of power, less electricity than the light in your refrigerator. And this ancient, underpowered machine that was only supposed to last 5 years is sending us information that is shaking the foundations of modern physics. September 5th, 1977. A rocket lifts off from Kennedy Space Center, carrying Voyager 1. The mission was simple: swing past Jupiter, swing past Saturn, take photos, collect data, then drift away into silence. Expected lifespan? 4 to 5 years. Space company planned to celebrate the mission's end by 1981 or 1982. What actually happened is one of the most extraordinary things in the history of science. Voyager 1 didn't go quiet. It passed Jupiter in 1979, sending back the first close-up images humans had ever seen.
It passed Saturn in 1980 and kept going, using planetary gravity as a slingshot to accelerate.
By the 1980s, it had already traveled farther than any object humans had ever sent into space. And it was still transmitting. Then, in 2012, 35 years after launch, Voyager 1 crossed the heliopause. If you've never heard that word, it's the single most important boundary in our cosmic neighborhood. The sun doesn't just provide heat and light. It constantly releases charged particles called the solar wind, which blows outward in every direction, forming a giant protective bubble around our entire solar system. That bubble contains every planet, every moon, every spacecraft we've ever launched, and everything alive. In 2012, Voyager 1 crossed through that boundary and became the first object in human history to leave the solar system. Not a metaphor, the first physical object
we've ever sent into the actual space between stars. And then it kept transmitting.
We now have a live instrument sitting in interstellar space, not orbiting a planet, not floating in the outer solar system, but actually inside the dark, cold space between star systems. A space no scientist had ever been able to observe from Earth. And what it's telling us is not what anyone expected. For decades, scientists built detailed mathematical models describing what interstellar space should look like. Those models all told the same story. Interstellar space should be relatively quiet, relatively smooth. A thin, cold, sparse environment where not much happens. Voyager 1 walked into that space and found it was actually a storm.
Starting in 2017, the plasma wave instrument on Voyager 1 began detecting something that nobody expected: a
constant hum in the fabric of interstellar plasma that, according to every model, simply should not be there. This wasn't a one-time burst. It was time. It was a continuous signal, year after year. Detected across a stretch of space 10 times longer than the distance between Earth and the Sun. Scientists publishing in Nature Astronomy were clear. Interstellar space is not the quiet void that models described. It's turbulent. It has structure at every scale. It's alive with motion and complexity. That was completely invisible to us because we'd never had a single instrument inside it before. Every model built to describe our universe beyond the solar system was built from outside looking in. Now the first instrument inside interstellar space is telling us those models were fundamentally incomplete. Now let's talk about what's happening right now, in 2026, because the story is entering its final chapter. Earlier this year, NASA shut off one of Voyager 1's instruments, not because it stopped working, but because Voyager 1 is running out of power. Voyager gets power from radioisotope thermoelectric generators, basically containers of plutonium-238 that produce heat as they decay. At launch, they produced around 470 watts. Today, nearly 49 years later, they produce roughly 200. They lose about 4 watts every year. In the early 2030s, the output will fall below the minimum needed to run any remaining instrument. Voyager 1 will go permanently silent. Of the 10 scientific instruments Voyager 1 launched with, 7 are already turned off. Bolted to Voyager's frame is the Voyager Golden Record, a gold-coated disc carrying greetings in 55 languages. The sound of rain, ocean waves, human laughter, 90 minutes of music from human civilization, diagrams of physics and mathematics, and a map of pulsars showing where Earth sits in the galaxy. Carl Sagan called it a message in a bottle, cast into the cosmic ocean. That record will still be traveling when the sun becomes a red giant and swallows Earth's orbit. It will still be traveling after every human city and archive has been erased by time. It's the most permanent thing our civilization has ever made, riding on a spacecraft that runs on less power than your bathroom light.
Right now in 2026, the only live scientific instrument humanity has ever placed in interstellar space is 48 years old.
Built using technology that predates personal computers, powered by less electricity than your kitchen stove light. And it's sending back information that is changing how we understand the universe and our place inside it. There are questions about the universe that can only be answered from inside the universe, not from a telescope on the ground, not from a satellite in Earth orbit, not from any mission to Mars or the asteroid belt. Only from a machine that crossed the heliopause, and as long as it is still transmitting, we need to be listening. Because when it goes quiet, some of the most important questions we have ever asked will go quiet with it. The signal is still coming, stretched across 15 billion miles, carrying information about a universe that is stranger, more turbulent, more connected, and more extraordinary than any model built from Earth ever correctly described. One machine, 4 watts, one chance to listen. The question is anyone paying attention? If you enjoyed this video, please subscribe to our channel, like this video, and share it with others.